Hey folks, today we're going to be looking at this problem called remove colored piece if both neighbors are the same color. So this is one of those problems which has quite a lot of instructions, but when you try to think about it, then the solution becomes quite easy. So you're going to see that the lines of code I think is going to be less than 10 or 7, something like that. So the solution is going to be quite intuitive. Anyway, essentially how you can think about this problem is that we have two players and they're playing a game whereby they have to remove colors, right, from the array. But there is condition on how they have to remove colors. So, for instance, the first player to remove a color, his name is Alice, and this player Alice is only allowed to remove a piece of color A if both the neighbors are colored A. So she's not allowed to remove pieces that are colored B. So what this means is that if we have like color A, color A, color A, B, B, so Alice can move this A because of the neighbors, it's A and A. So she can move. This is correct. But Alice cannot remove B. So if you had B, 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 she cannot move. So she lost, right? So now we come to this. So they say Bob is only allowed to remove a piece colored B if both the neighbors are also colored B. He is not allowed to remove color A. So it's the same thing, but now for B, they are only allowed to remove B, right? So as long as the neighbors are B, then they can remove this. So in this case, B is gonna be able to remove. But B was not gonna be able to remove if we had B and B, right? So you can't remove because the neighbor here the neighbor of the speed, like it was supposed to be like this. The neighbors are supposed to be BB, so you're not supposed to be alone, like, right? So that is quite important also. Then we're told that Alice and Bob cannot remove piece from the edge of the line. So which means that if we have like A, right? Um, Ellis can only remove this, right? He cannot remove this because this is at the edge, it's at the starting, and this is at the end. They cannot remove this. So if we had like you cannot remove anything. Alice cannot remove anything because these are at the edge. Both of them are at the edge. Okay, so we are told that if a player cannot make a move on the 10, that player loses and the other player wins. So when Alice wins, we return true, right? When Bob wins, we return false, right? So that's the also important consideration. False means Bob won, and true means Alice won. For us to understand much better, let's look at an example. So we can see that, okay, in this case, Alice won, but how did she win, right? So we can see that we have this array. So that means that she removed this, right? She removed this A, then the array was like A, B, A, B, B, right? Because if she removed this A, so now the array is like this. It is Bob 10. Bob now has to move. So let's see where will Bob move. Bob cannot move this because of the neighbors are not B. Bob cannot move this because the neighbors are not B. Bob cannot move this because this B is at the edge. So it makes sense why this is true, right? Because in this case, Bob at least clearly won. But now the question that I'll ask you now is that what if we had a a who will win? Let's say that the input was like this. Who's going to win in this case? So clearly Bob is going to win because Alice always start first, right? So when Alice start, she will realize that, oh, I can't move anything. I can't move this because this is at the edge. I can't move this because this is at the edge, right? So and there's also no neighbors anyway. So this is where we're gonna return false, meaning that Bob won this time. Okay, now we need to think about the solution, right? How can we solve this problem? So imagine if like we had an array like this, and now we need to write the code that is going to determine who's going to win given this array of colors, right? So the first thing that we should do is that, okay, we know that, okay, we're not going to consider the edges. So the edges we're not going to consider, which means that our loop should start somewhere around here and probably end around here because of the edges we're not going to consider. Then we check, we write a loop to check if the current pointer. Let's assume that this pointer, we call it I. If I, right, is equals to A, right, and we check the neighbors. We check the neighbors. Let's say the neighbors are going to be denoted. Okay, let's just say the neighbors are going to be I minus 1, right? So I minus 1, which we're talking about this guy here, are u equals to a, and I plus 1 are u equals to a. So what we're doing is that we're checking if this guy here and this guy here, are they equals to a. If they are, then we know that a is going to be plus equals to 1. We're going to increment for Alice. That's a point, right? And we're going to have an else statement, if statement, because of this might not be an a, it might be a b. So if I is equals to b, and we're doing the same thing, I minus 1 equals to b, we're checking if like it has valid neighbors. I plus 1 equals to b. Then it's going to be a point for Bob. Bob equals to plus 1, right? So now let's go through the algorithm. So now we know that, okay, this is not A, so this code here won't execute. This code also won't execute because the neighbors here are not B. So we come here, we move here now, our I is here, it checks, okay, this is not A, so this code won't execute, but this code is going to execute because this is B, and these neighbors are B. So which means that Bob, which was currently at 0, is going to be plus 1. So Bob is going to have point of 1. A is still at 0. So we move our I, we come here, we do the same thing. Wow, Bob won again. So it's gonna be 2. It comes here, Bob wins again, right? Because we can see that these conditions is gonna execute because of this. Neighbors are valid and these are not the edges. So we come back, we come here, Bob wins again. We come here, Bob does not win because of here it's A. We come here, no one wins because of obviously this the A here is not there, it's not an A here. We come here, we will won't come, we won't like go to the last element because of we don't consider the edge, so our loop has to like loop here, right? Like we just have to loop here. So we will consider this as neighbors but not as like the main color that we have to take. Anyway, hope that makes sense. Let's code it up. As I said, this is going to be quite easy to code it up. So the first thing that we're going to do is that we're going to have Alice, their point current is at 0. So this both of them, their point is going to be at 0 when we start. Then we're going to say for I in range, like I said, that we're not going to start at the edge. We're going to start at the next element. Then we're just going to make sure that the length of colors, right, is going to be minus 1. So this is because of also we don't want to like consider the edges, right? And we write the same code that we did. There's literally the same code, nothing changes. It's going to be if color I is equals to A, right? So and um, colors I minus 1 equals to A, and so here we just considering the neighbors, and colors I plus 1, so we just considering the neighbor, so it's gonna be A. And we don't have to handle like edge cases because of like we don't consider the edges, so that's why yeah, it's fine to say I plus 1, so we won't run out of bound. So it's gonna be Alice is gonna be plus 1, it's gonna get a point. L if it happens that the current element that we currently add is actually B, then we just need to make sure that that B is actually valid, meaning that the edges is going to be I minus 1 has to be equals to B. Probably there's a better way to write this solution. This is just what I came up with. I don't know if like uh, other people how they went about this, but anyway, maybe there's a better way to write this code. Anyway, so we have colors I plus 1, so that's fine. Then I'm just gonna say B plus equals to 1, so Bob got a point. Now we just need to make sure that if it happens that A is actually greater than B, so this means that we need to return true, right? So otherwise, we're gonna return false, right? So because of here, true Alice won, false means Bob won. So Alice has more point, it's gonna be true. Else Bob has more point, it's gonna be false. Also remember that there's a case whereby they can have equal point. So when they have equal point, Alice essentially did not win. So Bob won. So that's why here it's gonna be else, it's gonna be false. So that's an edge case that you should know that it's possible for them to have equal points. So when they have equal points, because of Bob is the last one to play, is gonna win. Okay. I don't know if this code will work, but let's give it a shot. I think it does. So let's submit and see if like all the cases passes, and they do. And this code looks efficient enough. So yeah, thank you guys for tuning in. This is quite an efficient solution. Yeah, I'll see you guys in the next one. Thanks. Bye.